In the last video, we were talking about some derivative rules, and we had the basics, the identities, dealing with the constant, the sum rule, the product rule, and the power rule. Then I posed the following question. What happens if you have f of x is equal to quantity 4x to the fifth plus 7 all to the 10th? Now, right now, based on our rule, we don't know how to do that. Actually, we do, but we'll come back to that. Because our rule says, or the power rule specifically, says what happens if you have x to the n when what we have here is we're taking this derivative with respect to x. So x to the n became n, x to the n minus 1. But here, this is not x to the n, it's something different to some power. Now, we actually do know how to do this because as horrific as this is, you could expand it using Pascal's triangle and then apply the sum rule, and there you go. But no one wants to do that. So we're going to come back to that in a second. Let's say I have $6. How many apples can I buy in Thailand? You might be saying, what? I don't know. Well, so here's the thing. What we want to know is how many apples $6 can buy. So what information would I need in order to answer this question? Well, the first piece of information you need to know is, well, how much do apples cost in Thailand? Let's say in Thailand, you can get 5 apples for 20 baht. The baht being the currency of Thailand, right? So 20 apples for 5 apples for 20 baht. So now I can solve the problem, right? Of course, the answer is no, right? Because I need another piece of information. $6, how many baht is that? Well, $1 US gives you, at the time of this filming, 31.2 baht. So there we go. So how would I figure this out? Well, let's work our way through this. We would take, I know how many dollars I have, and I want to end up with how many apples I have. So let's figure this out. What could I do? Well, I have apples and baht. Oh, I got it. I can multiply apples per baht times $1 US per 31.2 baht, right? No, that doesn't work, because then if you notice I've got 2 bahts in the bottom, that's not canceling out. Darn it. And I want apples on the top, definitely, because that's what I'm looking for. So let's try that again. 5 apples over 20 baht times 31.2 baht per $1 US, and then times $6 US. And if I do this out, I should get my answer. So let's see how many apples I can get. I can get a lot of apples. I can get 46.8 apples, or 46 apples, right? You can't buy 0.8 apples. So how about them apples? Haha, right? Now, you may be saying, like, what the hell is, what is Vaughn talking about? Like, why are we talking about this at all? Well, the reason is because we can't lose sight of something that's critically important about the derivative. The derivative at its basic is a ratio, right? When I write dy dx, I'm saying how a little change in x causes a little change in y, right? And that's just a ratio, not a rate, because it's not dt, a ratio. But really what we've done here is this is a ratio as well, as is this. So if I want to deal with ratios, I can always multiply ratios together, and as long as something links the ratios together, then I can do this, right? So if I know how a little change in x causes a little change in y, let's say I know how a little change in some variable, say u, causes a change in y, but I also know how a little change in x causes u to change. If I multiply these two things together, boom, I get dy dx because these would cancel out. I can even extend that further. dy dw, dw du, du dx, what have you, because those would cancel out, I'd be left with what I'm looking for. That's what we're going to do to solve this. Now that seems a bit of a stretch, but work with me here. So what is this? This rule is called the chain rule. The chain rule is our most versatile rule because the chain rule allows me to take something that doesn't look like one of our rules and make it into one of our rules. So what we're going to do is we're going to do this problem. I'm going to do it a couple of different ways structurally. First, kind of messy, and then second, in a sort of a neater format. And it's going to be up to you to decide how you want to do it. So f of x is equal to 4x to the 5th plus 7 to the 10th. Like I said, that doesn't look like one of our rules. But what happens if I change this and say something like, let u equal 4x to the 5th plus 7? So now I've got a really interesting thing because now I can write a new function, f of u, which is kind of funny. F of u equals, sorry, it's the little things that I use, is equal to u to the 10th, right? Now, I'm not going to call this y because f of x is y. F of u, I don't know, that's something else, right? But I can take the derivative of f of u, not with respect to x, but with respect to u. And that's a very simple derivative to take, right? Because using the power rule, I bring the power down and I raise it to the 1 less power, right? And look here, I can find how u changes when x changes by first doing some sum rule work, because we always want to show our sum rule. Okay, and then that is equal to bring the power down, so that's 5 times 4, or 20, to the 1 less power plus, and that just becomes 0. Great, so du dx is equal to that, right? So there we go. Beautiful. And now I can put it all together because I can do what dy dx is equal to, because that's equal to dy, which is du times du dx. Now in this thing, I could probably actually call this y because I've done it in terms of u. And so this becomes 10u to the 9th times 20x to the 4th. Now I'm not done there because I want how y changes with respect to x, and I have this u thing in here, so I'm just going to pull that back and do the resubstitution. Okay, to the 9th times 20x to the 4th. Now, I could combine this and move it around. I don't need to. I'm done with all my derivatives. And there we go. And look, there we have it. There's our answer. This is the right answer. Now, what's another way structurally to do this? Well, notice here what I did was I did everything in separate parts. Another structure I can use is I can say, well, if y is equal to 4x to the 5th plus 7 to the 10th, then dy dx is equal to, and just show my chain rule, dy du dx, right? And then, I would have my let statement here, and then I would write the following. So d, and then what I would show here is u to the 10th, showing that substitution, du and then times d, and what I would do is in place of the u there, I would put the let statement, okay, dx. And the next term here, using liberal use of parentheses, 10u to the 9th. And then here I would once again show my sum rule, ddx of 4x to the 5th plus ddx of 7. And then finish it off 10, and then resubstitute 4x to the 5th plus 7 to the 9th times 20x to the 4th. Boom, and I get the same answer. Okay, so two sort of structures. Some people like to do it in separate steps and then show the chain rule and combine them. And then if you want to start with the chain rule and then do everything sort of internally, that's just a matter of your preference there. But at the end of the day, what we're going to do is we're going to make our lives a little bit easier here, because notice here I have a bit of a pattern. The pattern here is this is the power that the function was raised to, right? Where this was our function, right? Here's the original function raised to the 1 less power. And here is the derivative of that function with respect to x. So as a new rule, what we can do, and actually let me just do it on a clean sheet of paper here, is we're going to write something called the power rule for functions. And it's going to internally combine the chain rule with the power rule. So what does that look like? If I've got something that has the general structure of u to the n, right? Notice here we're taking the derivative of something that's not x to the end. It's some function of x, right? Here the assumption here is u is a function of x, okay? And that becomes bring the power down and take the original function, u, raise it to the 1 less power, n minus 1, times the derivative of that original function, okay? And there you go. That is the power rule for functions. It is a shortcut that lets us do a lot of really interesting problems from there. And so with these rules now, you know enough to do the derivative of any polynomial function or multiplication of polynomial functions. After we're comfortable with that, we'll move on to the other types of functions, our transcendental functions, our trig functions, exponentials, and logarithms.